All right, so we're going to look at how to use conversion factors to solve a problem with dimensional analysis. So on the slide, I gave a kind of a scenario where you are holding a party and you've invited 42 people, so that makes a total of 43 if you include yourself. We're pretending you live alone. You want to make sure that you've got enough sodas for each person to have two, so 2 sodas per person. But the type of sodas you're buying and the store you're buying them at only sells that soda in 12 packs. And each 12 pack costs $4.44. And you also know that your state has a 7% sales tax. And you're wanting to know how much total money do I need to bring to the store for the sodas. Okay. On the previous slide, I put together a whole bunch of conversion factors for you. And I've got just the basic ones here. You'll notice that on the slide I had, 2 sodas equals 1 person equals 2 sodas, and then I had the 2 ratios. And so I had those 4 statements, I guess, or conversion factors for each scenario. But for dimensional analysis, writing it as a ratio is going to be the most helpful. So I'll refer to this, excuse me, the bell rang. All right, so I'll refer to this, this sheet of paper and these conversion factors instead of the slides, but they're written on the slides as well. Okay. So the first thing we want to know is, well, if we have 43 people, how much soda do I need? And a lot of people can do that in their heads. However, I'm going to show you how the conversion factors can be used with dimensional analysis to solve the same problem. The reason why dimensional analysis is so important and useful is that it helps you keep up with units. Okay? A lot of the time when you have a whole bunch of numbers and a bunch of different units and you're dealing with all sorts of different things, and it just gets kind of crazy sometimes, and people will accidentally divide when they should have multiplied, or they'll add stuff when there's no addition to be done, and they end up with some number that really doesn't make sense for what they're calculating. So dimensional analysis does a great job by using equalities to say, first I'm talking about 43 people. I'm going to see how much money I need to spend for 43 people. So you're going from people to money, and how do you get there? Okay, so you can use these conversion factors that are all equalities. We know 1 person, that means 2 sodas. 2 sodas is for every person, so that is an equality, and you can use those to get out of people and into sodas. So that's exactly what I'm going to do here. Okay. I start with 43 people, and we set this up like you're multiplying fractions. I'm going to show you 2 ways. You can put a little multiplication sign or a little X, and then draw your kind of ratio setup. So the way to do this is you always want your units to cancel so that you end up in a new unit. So let's do a little segue for a second. If I have X and I want to get into a Y, so I'm going to go from X to Y. And I know that X is equal to Y. All right, then I know that if X is equal to Y, then Y is equal to X. So X divided by Y is the same thing. It's just 1. So that's an equality as a ratio. And Y over X is also the same thing. So if I'm multiplying by fractions to help me get out of units, these aren't going to help me. I need to pick which way of representing this exact equality here is going to get me out of X's and into Y's. So I'm starting with X, and if I have to multiply it by one of those things, I'm going to have to pick something that has X in the denominator, because then I have X divided by X. Those X's cancel, and I'm left with just Y. And because X and Y are the exact same proportion here, right? So we've got X is equal to Y. So I could have said 2X is equal to 3Y and see how many Y's I need. You can do the same thing and throw numbers in front. But we see that X divided by X, so our units, we could throw any numbers in front, but the units, if you have them in the numerator and you need to cancel, you need to pick the conversion factor that has your desired unit on top and your unit that you want to cancel in the denominator. So that's how this would work. So kind of keep that in mind and just watch what we're doing. This will make a little bit more sense as we practice. So I've got people and I want to get into sodas. So I know that I want people to cancel out with something, and if I multiply people times people, I get people squared. That'd be like if I did X times x over y. You multiply across your numerators, you get x squared divided by y, and that does not get me out of x's and into y's. However, having x on opposite sides of these fractions do cancel. So I want my desired unit on top, so sodas, and I want people on the bottom, or person. We can kind of go back, but this is kind of where plurals are a little bit strange, but it wouldn't really change that. So here I know I've got 2 sodas per person, or 1 person for 2 sodas. I need to make sure that I have sodas on top, so I would use this conversion factor. It's the same exact conversion factor as that, it's just this gets me out of my units and it will do the right math for me. So I know that there are 2 sodas for every 1 person. Okay. And I'll see that people and person, that's just plural and singular for the same unit. Those cancel and I'm left with just sodas as my unit. Okay, now I've got 43 times 2, that is going to be 86. Now a lot of people would have done this in their head. That's cool. When you have a whole lot of consecutive problems to do, or you'll see a more efficient way of doing this here in a minute, you might not want to do just one step at a time, and so using dimensional analysis will be even more useful. Okay. Another thing people do, so I'm going to just rewrite this, is instead of putting a little x here, they'll do something called railroad tracks. So a lot of people would write it like this and put 2 sodas for every 1 person. And that way these lines kind of separate all your different units and numbers and values. And it would still work the same where you get 43 times 2 because you multiply across your numerator. Okay, and then your people cancel, so you're left with sodas. Okay, I tend to do this more, but I interchange them all the time, so just try to keep up. Let me get some more paper so I can kind of finish the problem. Okay. So that means now I've got 86 sodas that I need. So that still doesn't get me into money. I don't know the price per soda, but I do know that I know the price per pack, and I know how many sodas are in a pack. Okay, so if I'm going to buy my sodas, I need to figure out how many packs of soda I need if they're only sold in 12 packs. Okay, well, if they're sold in 12 packs, that means there's 12 sodas for every pack, or 1 pack is 12 sodas. I got to see which of these 2 conversion factors is going to get me out of sodas and into 12 packs. Okay, well, sodas are my units that I have now. They're in my numerator, so I'm going to put sodas on the bottom, so that way my sodas cancel, and I want to be in pack, or packs. And I know that there's 1 pack, or 1 12-pack, but instead of putting the 12 there and letting the numbers confuse everybody, I'm just going to say 1 pack has 12 sodas in it. That's why it's a 12-pack of sodas. Okay, so if I have 86 sodas and I'm getting into packs, I know my answer will be in pack, or packs probably, because that's not going to give me 1, so that'll be plural. And now I'm going to divide 86 by 12. But again, 86 times 1 over 12, it's the same thing as dividing 86 by 12. So one thing you could do, and I'll show you this here in a little bit, is you've got, your numerators are 86 and 1, so you can multiply across your numerators and then multiply across your denominators and divide the 2. But in this case, you say 86 times 1 over 12, that should be 86 divided by 12. Okay, so we're going to take 86 divided by 12, and you get 7.17. Okay, so we need 7.17 packs. Now, notice how in my calculator, let me try to turn it so you can see. In my calculator, I just did 86 divided by 12. If I want to do, 86 times 1, I get 86, and then divided by 12, you can do that. But we all should know that 86 times any number times 1 is just that same number. Okay. If this wasn't 1 on top, you could have done that same method, or what you could do is 86 times, use parentheses to express this fraction here, 1 divided by 12, and you still get the same number. So there's a few different ways you can do this in your calculator. I would choose whatever method you are most comfortable with, and we'll get lots of practice in class. All right, but, so yeah, you need a little over 7 12-packs, but you can't buy 7 12-packs and then part of a 12-pack. You got to have more than 7 12-packs, but you don't need fully 8, so you'll have some leftovers probably, definitely. So you can't buy that. 0.17 packs. So to have exactly the right number, that means you'll need to get an additional pack. So you need 8 12 packs. And that's going to make sure that you have enough for everybody. All right, well, if we need 8 12 packs, we can see how much money that should cost us before tax. Okay, 8 12 packs, if each pack costs $1.44, or I keep saying $1.44, $4.44. I've got this relationship here. If I'm spending $4.44, I'm buying 1 12 pack of soda. If I'm buying 1 12 pack of soda, I'm spending $4.44. So since I've got packs on top, all right, that means that I want to get into money. So I'm going to write dollars right now and packs on the bottom. And we know that there's $4.44 that are going to be spent on 1 pack of soda. Okay. So here my packs cancel and I'm left in dollars. Kind of separate these. All right. And see how this is 8 times 4.44 over 1. So since it's over 1, you can just ignore that. If this was not 1, you'd have to do some more math. But you get 8 times 4.44, or you'd multiply across your numerators. So now we got 8 times 4.44, and we have $35.52. So that means that before tax, you're going to spend $35.52 on soda. But you've got sales tax, so you're not. If you only brought $35.52, that would not be enough money. So to figure out exactly the right amount of money you would need to bring, you're going to have to calculate how much tax you're going to be spending. So your state has a 7% sales tax, which means that for every dollar you spend, you pay 12, or not 12, where am I getting 12 from? 12 packs. You pay 7 cents, okay? Well, or you spend 7% of that. And the percentage, remember, is per a 100, so 7% would be 7 out of 100. And there's 100 pennies in a dollar, so that's where that 7% comes from. So if I spend 100 pennies, I'm paying 7 pennies in tax additional. If I spend 100 pennies here, I've got 7 pennies that I owe in tax. So here, I'm going to try to figure out how to make these dollars into pennies just to make it a little easier. Now, if you want to bypass the extra math, I'm choosing to so you can see more dimensional analysis. If you want to bypass that extra math, you could write this exact same thing as 7 pennies per dollar spent, per $1 spent. You could even go so far as to say that 0.07, that's a 7%, okay, pennies, well, we'll say dollar, it's $0.07 in tax for every $1 spent. Okay, this is how I would do it if I wasn't showing somebody how to do dimensional analysis, but we'll do the long way just so you can see that process some more. All right, so that's how much money I'm going to spend. So $35.52 spent. And I want to get out of dollars spent. Okay. And I know that I need my tax in pennies since that's my percentage the way that I've written it. Okay. So I need to get out of dollars spent and into pennies spent. Okay. Well, we know that there are 100 pennies in $1. So if I spend $1, I'm spending 100 pennies, and that's the same thing, it's just different units. So now my dollars spent cancel. I'm left in pennies spent. And I've got 35.52 times 100. Okay, this is times 10 times 10, so we're going to move my decimal place to the right 2 times. So we get 3,552 pennies spent. Okay, well, if that's how many pennies I'm spending, I can see how many pennies additional tax I'm going to need using this conversion factor. So 35.52 pennies spent means that for every 1 penny, or 100 pennies spent, I'm paying 7 pennies in tax. So my penny spent will still cancel, and this is going to tell me how many pennies in tax I owe. Okay. This is a good example of kind of when you have a conversion factor where either the numerator or denominator is not 1. Okay, so I'm going to take what I'm given, so 3,552. Okay, a couple ways. You can take that and multiply across your numerator, so times 7, get that answer, and divide it by your denominator, so divide it by 100. So you could totally do that. Okay. You can also, and this is the way I like to do it, just go ahead, and it's less stuff to plug in as long as you make sure you use your parentheses, and do this as a fraction, 7 divided by 100. So I've got what I was given, the 3552 times, parentheses, 7 divided by 100, parentheses. It still gives me the same answer. So I'm spending or in tax at least, 248.64 pennies. Well, we can't have part of a penny, so really 249 pennies in tax that I'm going to be spending. Okay? So if that's how much I'm being taxed, and it's in pennies, and this is how much the sodas cost me in dollars before tax, I need to get these into the same unit and then add them together for the total. So, oops, sorry about that. So what I'm going to do, let's get some more paper, is now take, if I'm spending 249 pennies in tax, let's put them back into dollars, because you would talk about money in terms of dollars and not in terms of total pennies. So that means that I need to get out of pennies tax and into dollars of tax. We know that for every $1 of tax, that's 100 pennies. Okay. So I'm going to do 249 times 1/100th, or 249 divided by 100. That's going to give me dollars in tax. So I'm going to take 249 divided by 100. It's 2.49. Okay, what I would have done is I know that that 100, if I'm dividing by 10 2 times, I'm going to just move my decimal place right here between the 2 and 4. And so I'm spending that much money in tax. So I could write that as 249 in tax. So my total would be the cost of soda plus sales tax. Okay? Tax. So the cost of the soda before tax was $35.52 plus $2.49 in sales tax. So $2.49 plus $35.52. So I'm going to need $38 and a penny exactly to buy the proper amount of soda. But doing so many problems takes some time. So if you look at my next video, you'll see that I can do the exact same problem, exact same math, keep up with my units way faster. So tune in.